Okay. So in this chapter, first chapter, we talk about introductory concepts, right? So data science is a broad field, and it brings in lots of different technical knowledge, okay, for problem solving. And these are the major functional areas, okay, functional knowledge that the data science is based upon. Okay. So you need to have statistics knowledge. So that's the first thing, statistics and mathematics. Okay. Now, you've had your statistics class, okay, which is just a starting point, of course, and we will not get too detailed into the technical aspects of the methodologies, okay, but they're all based on statistics, okay. So to the extent possible, I will describe or explain the statistical background of the methodologies, okay. But we will, our focus is going to be understanding how to apply those methods to problem solving, okay. And then there is machine learning. Machine learning simply means you look at the data, and the more data that comes in, the machine develops rules, okay, automatically. Okay. So that is what is called machine learning. So it's a part of data mining, and we will be discussing some methodologies that are applied in machine learning. Okay. The main thing in machine learning is, as new data comes in, you've already set up the model. Okay, like if you set up a logistics regression model or neural network model or decision tree model, you've already set it up, right? And then as new data keeps flowing in, that methodology is applied and the parameters are fine-tuned with new data. It keeps updating the parameters of the method. So the more fine-tuned the parameters are, the more accurate the predictions become. So in that sense, it's learning from new data. It's learning to come up with more accurate predictions. So that is machine learning. Okay. And programming, of course, is important, and we are not going to get too deep into coding, but we will have some coding, and I will go over those coding knowledge that we need. And business, of course, is what this is all about. So the application. So these are all the technical things, data and analysis and methodologies. All of those are applied for solving a business problem. So to that extent, then you need to know a good background of the domain that you're analyzing. So it's called domain knowledge. Okay. So if you, like for example, in an insurance company, there are claims coming in, right? Now you want to know whether the claims are legitimate or not. So you set up a model that analyzes the data and then figures out whether the claim is legitimate or not, right? So now I have described the method or described the procedure in a very broad sense, but to apply the methodologies in the most appropriate way, you need to have domain knowledge about the insurance claims. What are the important factors to consider to analyze the claims, to come up with a judgment? Okay? And how do you collect the data for those predictor variables? And what kind of limitations there are? And so the domain knowledge is again a very important part of data science. And then information technology, IT, the whole thing is based on running things in computers. So if you have some millions of records that are coming through, you need to have high performance machines that will churn through all the data and give you the information that you seek. So IT is another important aspect of data science. A given person may not be an expert in all of them, all of these different aspects of data science, but you need to have good background in all of them. Okay. So some terminologies and notations. Okay, and here I'm going to compare and contrast what terminologies are used in the classical sense. Okay, when you take your stat class 2120, these are the terminologies you're likely to have come across. And for some reason, in data science or data analytics, they use specialized terminologies because it's a little bit different. Okay? Now, in statistics, so you have independent variables and dependent variables, the x variables and the y variables, right? If you do a regression analysis, you have a y variable, y equal to b sub 0 plus b sub 1 x1, b sub 2 x sub 2, and so on. So the x's are the independent variables, and y is the variable that we are trying to predict. So y may be sales. We want to predict sales for the next quarter. And then you have several independent variables based on which you make the prediction, right? So those independent variables, which are the x variables in a regression analysis, in analytics, they're called either attributes of the observation. So it could be, so for example, in Spotify or Pandora, you analyze the songs and you want to make a prediction. So what are the characteristics of that song? So what is it, what genre, what kind of beat and what kind of instruments and so on and so forth. These are features of the observation. So attribute, feature, input variable, predict, these are the different, they all mean the same, they all try to refer to the same thing, right? These are the independent variables. These are the variables using which you're going to make a prediction. So that's your predictive model, right? So those are the independent variables, the x's. The dependent variable, the thing that we are trying to predict, okay, so that in analytics, they call it target. Okay. Target is what is very often used. Okay. Response variable, output variable are used less frequently. But you will often hear the term target. So target here means the y variable that we are, think about it in the terms of regression. So target is your y variable. Okay. That's what we are trying to predict based on the independent variables. Okay. Observation is each row in a data table. Think of a data table. Each row is an observation, and each column is a feature or independent variable. Of course, there's going to be a target.